So I'm going to talk about general ethical principles. I'm going to touch upon very shortly on privacy and on legal issues. And this afternoon, Damien is going to give a presentation more on the legal aspects pertaining to Africa. I'm not very familiar with that. Damien knows much more about that. So he's, like later this afternoon, Damien is going to complement this lecture with specific African and Nigerian topics. On Monday, I explained that this course is mainly about research use of EEG rather than clinical use of EEG. For research, we work with voluntary participants who, in principle, do not directly benefit from the research. In the long run, of course, we hope that they benefit from the research. In the long run, we hope that our research contributes to the welfare of the society and to healthcare, for example. But that is very different for clinical diagnostics, because for clinical diagnostics and treatment, we work with patients where each individual patient benefits from participating in the EEG recording. So what I'm going to do, as we've been doing so far, I'm going to look at the research aspect, not on the clinical aspect. So I will only consider research using EEG, so with voluntary participants. And what I already mentioned is like a volunteer or a participant or a subject. Sometimes they're used interchangeably. I think volunteer stresses the intention of the person who comes to the lab to have the EEG cap placed on the head. A participant makes it more symmetric, whereas the subject is basically me as the experimenter, and I just happen to have someone in the lab and I don't care about that. So a subject would be a more an appropriate term if you're doing an experiment with a specimen or with an animal. Although a lot of studies, a lot of methods are using the word subject, I think we should get away from it and we should start moving over to calling the people that come to the lab to participate in EEG research, to call them participants. And research using EEG is not only about the EEG data. I've shown this schematic a few times. It's also about the behavioral data. It's also about other types of data that we get from the participant. So we're going to talk about this participant and about all the things that we're going to do with this participant. So we're going to collect participant data, we're going to collect the EEG. For collecting the EEG, we're going to interfere with the participant, we're going to fiddle around with their head and with their hair, and we're going to have the participant do a task. Also, this task is interfering with the participant. Some tasks are very nice, some tasks are not so nice for the participant. So that is something to think about. The topics that I want to cover in this lecture are ethics, legal and moral considerations, the Declaration of Helsinki, which provides a very good foundation for thinking about ethics and moral aspects. Then I'm going a little bit more into the technical or procedural details on how we do EEG research. So I'm going to talk about informed consent and the screening form, and about incidental findings and adversarial effects. Something that I think is relevant to mention as well is that in certain experiments, on purpose, we lie to the participant. It's part of the experimental design. We tell the participant to attend one stimulus, and we tell the participant, oh, it's really important that you attend to one stimulus, but actually that's not really important for the research. Small lies are okay, big lies are something that we have to be more careful about. So lying to the participant is common, but we have to think about, like, is it a small or a large lie? Then I'm going to move over more to the aspects of privacy. So I'm going to talk about, very shortly, I'm again going to mention the GDPR, which applies in Europe in the HIPAA, data minimization, and I'm going to explain anonymization versus pseudonymization, which are strategies that help us so that we can share data or that we can also use data sharing agreements. Even though if you're not recording your own data, so if you don't have your own EEG lab, it helps to understand what the people that are doing an EEG lab, what they have to deal with, because at a certain point, you might have to draft a data use agreement so that other people can use your data, but it might also be that, as we looked at yesterday, that you're going to use data that has been provided by others. So understanding the limitations under which this data has been shared is important. So what data are we collecting? And what are we doing, like more general to our participants? So we collect data, we do experiments, so we manipulate. We cause them potential discomfort, like wearing the EEG cap. I would prefer not to wear an EEG cap, but the discomfort is not that large. But also we cause them potential harm, depending on the type of experiments that we're doing. And this is something that we need to consider during the experiment, but also afterwards. The Declaration of Helsinki is already a very long-standing set of ethical principles for medical research involving human subjects. And it already exists for more than 50 years, and it has been revised a few times. And what the Declaration of Helsinki does is that it emphasizes the rights that patients have. The Declaration of Helsinki has been drafted by the World Medical Association, so it talks about patients, but in a very similar sense, it also extends to participants that are not patients. So it also extends to healthy volunteers. It deals with ethical research conduct, scientific integrity, and ensuring that medical research prioritizes human dignity over scientific advancements. So it's important that the person who comes to our lab, that we take that person's right fully into consideration and that we're not abusing that person. For later reference, because you can download these slides, I've put the link to the Declaration of Helsinki so that you can actually read it yourself. Because a lot of people have heard about it, but not so many people have actually clicked on the link and read it. It's quite accessible. And the Declaration of Helsinki is directed at medical researchers, and not all our EEG research is medical, but the principles still apply to our research. So I suggest just go there, have a look at it. What I'm going to do is I'm just going to highlight the important topics that the Declaration of Helsinki deals with. So the Declaration of Helsinki is a list of topics, and each of the topics is like worked out. It goes about the primacy of patient welfare and well-being. The patient or the participant is more important than our research. It talks about informed consent. It talks about risk-benefit assessment. Risks might be small, but benefits are also small, so we have to put them on a scale, we have to weigh them. It talks about protection of vulnerable groups. It talks about independent ethics review. Declaration of Helsinki asks for respect of privacy and confidentiality. And it includes post-trial provisions. So this is something that doesn't generally apply if we do research in healthy participants, because we're not really doing clinical trials. So at the end of the trial, usually with research, there's nothing coming out that would be beneficial to our participants. But still, it is in there as well. There's research integrity and transparency. It's a physician's role and responsibility, especially if you're the treating physician. Then you have a specific responsibility because you basically have two different interests. On one hand, you have the interest in treating the patient and making sure that the patient's health improves. On the other hand, you have your research interest, which is more selfish. Balancing those is important. And the day before yesterday, when we did the EEG recordings I think it was with Group C, I've already been discussing that at the donors in general, we don't do recordings on family members. We don't do recordings on people that are hierarchically lower. So I don't do research on my students. Because if I tell my students, can you participate in the research? I'm basically wearing two hats. On the one hand, I'm the supervisor, I'm the boss. On the other hand, I'm interested in getting the research done. So what I would do is I would ask my students, can you find someone, like one of your friends, that doesn't mind participating in the research? Because these friends, I cannot boss them around. That means that if one of their friends comes over, I'm more confident that the person who then comes in the lab will tell me, oh, I don't like this, because there's no consequence. And it also talks about like prohibition of placebo and harm cases. So again, this is a very medical-oriented thing that is not really relevant for the research that we're discussing here. So these are all important aspects that we have to think of partially during, but also partially prior to the experiment. For example, selection of participants, in deciding who to invite, but also making sure that the procedures are in place prior to the experiment. During the experiment, we're also going to interact with our participant. And what we do is actually what we consider is it's not during the experiment where the participant sitting there with the EEG on their head, but it's as soon as we start interacting with the participant, we have to think, how is this interaction perceived? So there's an important principle there, is that we ask the participant for informed consent. And informed there means that the participant knows knows in advance what we're going to do. So that for us that means that when we invite the participant to the lab, we're going to provide the participant with information on basis of which the participant might decide not to come. So we send them information in advance, and we're not going to invite them in a lab so that they have a lot of travel time, etc. And then we're going to tell them, oh, we're going to do something that you might not like. So information is provided in advance, and then the participant agrees or does not agree, and that's also okay. But if the participant agrees to the information that we have provided, then we can proceed. So practically what we do at the Donders is we send an information brochure, and our procedure is to send it at least 24 hours in advance, so that the participant has time to read it, has time to think about it, has time to talk about it to family members, to people that are living in the same house, and to come up with questions. Our information brochures, so I explained at the Donders we have a lot of different methods for studying the brain. So we have information brochures that are general, and we have information brochure that is method specific. So the general section on so we have like a general information brochure. Oh, you're going to participate in research at the Donders. We're going to treat you well, etc. And then the second part is you're going to participate in EEG research. That means that we're going to put like a bathing cap on your head. We're going to squirt a little bit of gel in this. You have to sit still for a certain amount of time. You should not, preferably should not use products in your hair and wash your hair the day in advance. So those type of things are in the information brochure. And then very often, we would also add a study-specific part to the information brochure, which is about the goal of the study, who's carrying out the study, what the participant can expect in terms of the task that the participant has to do. So that might, for example, be, oh, we're going to induce a stressful stimuli. We're going to show you things that you might find nasty, but that is relevant because this and this and this. So that's not about the research method, it's not about the EEG, but it's about what we're going to do in terms of stimulus presentation. Once the participant arrives in the lab, we check whether the participant has any remaining questions. And that's also why it's important that the participant has the opportunity to think about this in advance. Usually participants don't have a lot of questions, or it's like a few minor questions. We try to answer them to the best of our ability, and then we ask whether they consent. And if so, they sign a form. So the researcher has a form in which the participant's name is put in, the date, and then the participant signs this form. This form is important also for the legal considerations afterward. This form is not part of the research data. So what we do is we keep these forms at our administration. We don't keep them in the researcher's office. Also, the participant is free to stop the experiment at any moment. So what we tell them is that if you feel uncomfortable, if you don't like it anymore, just tell us and we're going to stop the experiment. We do provide the participants with a small reimbursement for their efforts in coming to the lab. We're not paying the participant, we're not giving them a salary. We're also not allowed to give them salary, because then there would be an incentive, like an incentive to actually come to the lab and to make money. So we're giving them just enough that they have their expenses covered and their troubles covered, but not enough that that money would actually be the reason to come to the lab, because we want the reason to come to the lab voluntarily. So when the participant decides not to continue with the experiment, we're still going to reimburse the participant, because the participant came to the lab, so he deserves the payment for that. It does not happen very often that a participant bails out halfway the experiment. But if it happens, the participant should not have any negative consequences of this. The informed consent form with the name and the date and the signature is stored at administration. And according to Dutch regulations, we have to archive it for 10 years. So that's a little bit annoying, because that means that we have to keep track of all these informed consent forms. And to just give you an idea, at the Donner Center for Cognitive Neuroimaging, we have about 5,000 participants every year. So there's actually quite a bunch of we have all of these labs. So together over all of these labs, we have about 5,000 participants. So that's quite a lot of informed consent forms. So the administration keeps them organized and puts them in a folder. And basically on the folder it is written, these informed consent forms can be trashed in 2035. So in 10 years from now. We hardly ever have to look at them again, but we're required to keep them, and we're also required to keep them in paper form because the signature is on it. So that is something that might change in the future. Perhaps we can keep them digital, but also if we keep them digital, we're required to keep them for 10 years, but we cannot keep them longer than 10 years. So after 10 years, someone has to go and has to delete them. We do not keep the informed consent form lying around in the lab because it has the name of the participant and the signature, and that might actually leak personal or potentially health information from the participant. If the informed consent form, for example, states you're participating in this Parkinson study, or you're participating in this depression study, and then the participant signs, of course there's not only the name of the participant that is potentially leaking out, but it's also that the participant has a certain diagnosis. So that's why we keep them safe, and directly after the experiment we bring them to the administration. So this is still at the moment when the participant has just come into the lab. We're just like having a chat, we make sure there's no questions, participant signs, and at the same time we also do the screening form. The screening form is something that we do send the participant also in advance, so that the participant can already think about this. And the screening form lists a few exclusion criteria. One of the exclusion criteria, so since we're doing both neuroimaging and MEG and EEG, our screening forms are quite strict because the screening forms are primarily focused on the neuroimaging. So in our center, we're not, like an exclusion criteria is if the participant is pregnant. Pregnancy in EEG, there's not really a problem with that, but pregnancy in an MRI scan is something that we're not allowed to do. Like we cannot put the fetus in a very strong magnetic field, even though I personally don't think that it would harm the fetus in any way, but we're not allowed to do it. So that means that if there's a chance of including an anatomical MRI scan for source localization, well, then you would get an anatomical MRI, and then the participant has to go in an MRI scanner. So that's why pregnancy, in the case of EEG, is also not indicated. Another reason for excluding pregnant women is that we tell the participant to sit still for a long time. And sitting still for a long time can cause discomfort. So then we have to balance, okay, so some participants will just move to keep, basically for the comfort, and then we might say, oh, you have to sit still. And then we're basically doing something with the participant that might be uncomfortable and that is not necessary. So that's why we're only including participants that are not pregnant. There's a few more of these exclusion criteria. Most of them have to do with safety for the participant. Some of them have to do with making sure that our sample includes the right participants. Previous neurological or psychiatric conditions is an exclusion criteria. We do research on healthy subjects, so we don't want to have any potential risk of including a non-healthy subject or a potentially non-healthy subject in our studies. Having metal implants, or having worked in metal industry. So like if you have worked in metal industry, it's actually quite common that people would have small metal splinters in their fingers, sometimes in their eyes. We don't want to put those people in the MRI scanner because the metal might start moving, and that would just be risky. So there's a list of these exclusion criteria that we check. Most people pass these exclusion criteria without any hassle. If the participant fulfills the study requirements, so no medical or mental conditions, capable of doing the task, proper eyesight. So proper eyesight is sometimes also like with EEG, you can put on glasses. In MRI scanner, you cannot wear your own glasses. So we have like some plastic glasses that we can use in an MRI scanner, but they're actually relatively uncomfortable. So we'd rather have people wear contact lenses, or if they wear glasses, then they have to be aware that they have to wear other type of glasses. So if you have very complex glasses, well, then the participant is not really suitable for inclusion in some of the studies. Then we do the experiment. And what might happen is that we have an incidental finding. So we notice something in the data that we were not looking for, but that may be clinically relevant. And in our case, it mainly happens with anatomical MRI scans. So here you see an example of a very small lesion in the frontal part of the brain. And actually, at the DCCN, we do about 3,500 MRI scans a year. And we know from the general population that a few percent, I think it's about 4%, also 4% of you guys, will have a structural abnormality in your brain that you might not be aware of. If you go in a scanner, we're going to see this. So that means that we have, every week, we have 1 or 2 incidental findings. We have someone in an MRI scanner and we see something, It's not directly dangerous for the participants. If the participant had not participated, he would probably never have found out. But we have an incidental findings procedure. So we are required to follow this up. So what we do is, so not reporting it to the participant is not an option, as it's not ethical to the participant, but it's also not ethical to the researcher. Imagine that I would see that you have an aneurysma, like a large aneurysma. And so I know that you're at risk for a stroke. So if I would not be allowed to tell you, I would be in stress. So the informed consent, the incidental findings procedure is both to protect the ethics of the participants, but also the ethics and the morale of the researcher. So our procedure consists of, if you see something that you think is not okay, potentially not okay, well, first of all, we're researchers, we're not clinicians, so we cannot really judge. So the first thing that we do is we have it reviewed by someone who is better trained, still not a doctor, but someone who's better trained in reading clinical MRI scans. So that person might then say, oh, this indeed might be something. Then, since we're not clinicians, in our case, we're not doing further medical research. So in our case, we're not going to directly tell the participant, but we tell the participant that the participants should contact their general practitioner. We're not telling what we've seen because our scans are not designed for clinical diagnostics. So the participant can request their scan. The participant can always request the data, but we're not going to give a clinical diagnosis. Where you just tell the participant, we've seen something that is potentially of clinical relevance, so please discuss this with your GP. And then the GP will typically ask for the scans, we'll have a look at it, or we'll discuss this with a neurologist, and then follow-up research might be planned or might not be planned. So it is important that in our center, most of the research are not trained as doctors, so we cannot do clinical diagnosis. And our scanners are not meant for clinical diagnostics, even though our scanners are better than the ones that they have in the hospital, but still our scan procedures are not designed for this. In EEG, we don't see a lot of incidental findings, but there are a few incidental findings that we might observe. For example, epilepsy. To be honest, I've never observed epilepsy. I would also not be able to really recognize it. If there would be a little bit of intra-equal spiking, for me it would be difficult to distinguish this from other types of artifacts. Something that we have seen a few times is heart rate irregularities. But it really rarely happens because we don't standard record ECG. In a lot of participants, we don't see a lot of ECG artifacts. So most of the time, even if it were there, we would not see it. And if we don't see it, then we don't have to investigate because the participant did not come to the lab for a clinical investigation. The participant came as a volunteer for research. So if we don't know anything about it, we don't have to report anything either. A second thing that can happen during the experiments is an adversarial effect. So that means that our intervention, our experiments, our measurements has an unexpected effect, something that we were not expecting and something that we would rather not have happening. For example, the application of the EEG gel causes a skin rash. Perhaps the participant is allergic to something. Or like in the MRI scanner, the participant becomes claustrophobic. It's a pretty narrow tube, you have to lie in it, there's a lot of noise. Some people don't like it. Some people really don't like it, so they want to get out. That's what we say, that's an adversarial effect. We don't want the people to get anxious, but it can happen. Or the participant actually gets hurt while in the lab. Just the participant comes in the lab, stumbles, falls, hits their head on the table, okay. Bad things can happen. Could also have happened in a canteen or any other building on campus, but it happens in our lab, so we're responsible. And as part of the ethical approval for our studies, we are required to have an insurance for all our participants. So if a participant gets hurt, we are responsible for taking up the medical costs. Doesn't happen a lot, because of course we make sure that both for our employees, for the researchers, and for our participants, that we have a safe working environment. And we make sure that we, for example, make sure that our participant does not, so we use clean needles for every participant. We disinfect the cap in between of experiments. So we have a lot of procedure in place to make sure that every participant basically comes in a clean lab and that the lab is well organized, that there's no cables for tripping, etc. So this is not really something that happens a lot, but sometimes it happens. To just give an example, once we had an EEG recording, and during the EEG recording, what you've also seen, you put the cap on, the cap is pretty tight, so sometimes you get these red spots on your skin. And for me, the red spots would show quite clearly. For you, they might show less, but you get these dimples. Turned out that the participant had planned a photo shoot in the afternoon. So the participant was really ready to get all dressed up to go in a photo, and then she had these dimples on her forehead. So the participant complained, rightfully so, and because she had scheduled the photo shoot and she had to pay for it. Okay, so that's where we step in, and our insurance then has to pay for the photo shoot so that she can get it redone on another day, so that she gets nice photos of herself. So this is really something that is unexpected, doesn't happen often, but it's something that you have to be aware of. And you have to take responsibility for this. I already mentioned experimental tasking and being honest. In general, we try to be as honest as possible to the participant, but sometimes part of the research question cannot be disclosed. Sometimes the research question is too complex to explain or it's not really relevant. But sometimes we, on purpose, don't tell what the participant actually is doing, because that would mean that the participant is not doing the task properly. For example, we tell the participant that they're going to get extra money if they perform the task very well. All right, so that's going to be a motivating factor. The participant is going to try really hard. Okay, but it's not fair that the amount of money is going to depend on how well the participant has done. So in the end of the experiment, they're going to get the maximum amount anyway. So that's a small lie to just motivate the participants, to get the participant engaged in the task. Or we play with the participant's belief. So we tell that something is simple, whereas actually it's pretty difficult. So that might cause the participant to get frustrated. So this frustration is something that we can play with. But if we tell in advance, we're going to tell you something that's going to make you frustrated, well, he's not going to get frustrated. Or we have the participant believe that there's going to be a very unpleasant stimulus. So we have like an electrical stimulator, you can put it on the finger, and you can give electric shocks. And we let the participant feel it a few times, and when I say, oh, if you do the task really bad, we're going to crank up the volume. Like we're going to make it more unpleasant. Again, this is going to induce stress. And of course, we're never going to really make it unpleasant for the participants. But if we want to study stress, we have to make sure that the participant is stressed to a certain level. And that allows us to study anticipation and stress. So in all of these cases, we're using small lies to have the participant do the task in the way that we want. Small lies are common and they're allowed, so that's also actually what's in our ethics application as well. So for example, to tell the participant that to press a button on a specific stimulus, whereas actually the stimulus doesn't even matter, it's just to keep the participant occupied. But there's also larger lies. And these larger lies, we have them evaluated by the ethics committee. And a very well-known example of a very large lie that was in a psychological experiment, I think it was in the 60s, is Milgram's experiment, where he put people in a situation where they would enact either prisoners or the people taking care of the prisoners. And it was basically like a power relation, and it led to very nasty interactions between the prisoners and the guards. The guards were basically making abuse of the situation, and that has come as a very clear example of how we don't want to treat our participants. So if you don't know about Milgram's experiment and the consequences that it has had for research, you should really look this up. So small lies are okay, big lies, you have to be critical about this, and that's where the ethics committee can help. Okay, so at a certain point the participant has left, and after the experimental interaction there's still a few things that we should think about. And that is primarily has to do with privacy and with personal data. So we collect personal data from our participants. So we have demographic data, the age, education. We potentially have health data. We have behavioral data. We have questionnaires. And it might cause harm to our participant if that data were known to external parties. So that's why we have to think about the privacy. And the strategies that we use are data minimization, pseudonymization, and blurring. And let me go over these individual. So the types of personal data that we record are, for example, the name, the address, the date of birth, phone numbers so that we can contact the participants. But there's also like things such as license plate number where we don't collect that. But if we do online experiments, we might collect the IP address. The IP address might be the same as like the home address. And directly identifying personal data, what I always think about is like what would a police officer search for on the crime scene in order to identify the person quickly? So you find this murdered person. So the first thing you're going to do is you're going to feel the pockets to see whether they have a passport, a driver's license, a wallet. So it's the stuff that you have in your wallet is the directly identifiable personal data. In case the police officer does not find a wallet or a driver's license, there's other data that you can use to identify the victim. For example, the fingerprints or the facial details or the dental records or genetics. And there's a few things that are very similar to these fingerprints. So genetics are unique for everyone, fingerprints are unique for everyone. The cortical folding pattern that we can record and that we can reconstruct from an anatomical MRI is very much like a fingerprint. It's not that you have your cortical folding pattern stored in a database, but if you were to participate in two studies, your cortical folding pattern could be linked between these two studies. The same also goes for responses to a questionnaire. And EEG, I'm not really sure. I think EEG is typically recorded in such a setting that if you do two EEG experiments on the same participant, it's going to be very difficult to link one EEG recording to another EEG recording. But there have been some studies that have looked at similarity, like multiple sessions recordings, and the EEG patterns of one participant are constant over time. So as such, EEG in the future potentially might become seen as a fingerprint. At this moment, we don't have the methods for this yet, and also every EEG system is different, every task is different, but I'm not ruling out that EEG in the future might be considered similar as fingerprinting. So personal data is needed because we need to contact the participants, and it should be managed. So we require this for administration. We pay our participants a small fee for their participation. We have to follow up incidental findings, but it's not required for addressing the research question. Sometimes we use this type of information to model a confound. For example, if we know that certain areas in the city are richer areas and poorer areas, that is something that we want to model in our analysis. We want to use it to check whether the sample is representative, or sometimes it's needed to ensure scientific integrity. But in general, what we do is we keep the personal data separate from the research data, and we discard it as soon as we can. An important principle here is to do data minimization. So we record as much as needed, but as little as possible. So we might record some details about like some personal data items, but we're not going to ask everything. So we would ask enough so that we can contact the participant and that we can pay the participant. But for example, in the Netherlands, we would not ask our participants their social security number, because it is not necessary for us to know this, and knowing the social security number actually makes it risky to link them to other databases. I know that in Denmark, where Mikkel is working, the situation is very different. So there the social security number is used much more widely, and they are asking the social security number is a common practice as part of the payment procedure, etc. So this really depends per country. There are specific types of personal data that are, according to law, are considered as special. Race is one of them, religion or beliefs, the health situation, sexual activities, political preference or being a member of a union, but also the criminal records. Those are things that we're not allowed to collect if we do not have special permission for it. So we're not registering the ethnic background of our participant because we're not allowed, because in most cases it is not relevant for answering the research question. Of course, if it is part of the research question, well then you have good reasons to collect it. But in general, we don't collect it. We're not going to ask the political preferences, we're not going to ask if someone is a union member, because these are seen as things that invade the privacy of the participants too much. So we are only allowed to study this if they're really part of the research, or to collect these if they're really part of the research question. And also in the indirect personal data, so that is where the research data comes in, that can identify someone when linked to another database. So with fingerprints, fingerprints are potentially identifying because there's a lot of databases. When I entered Nigeria, I had to give fingerprints. So your government now has my fingerprints. The American government has my fingerprints, the Dutch government has my fingerprints. So my fingerprints are all over the place. So it means that a lot of authorities would be able to link my fingerprints that I give in an experimental study to my identity. DNA, I don't think that my DNA is any database, but it could happen, right? Facial details, yeah, definitely. My facial details are all over the internet. My anatomical MRI, okay, I've used it in a few of the tutorials. So my anatomical MRI is now also more or less in the public domain. But in general, that is something that would not be available to other people. So your anatomical MRIs, I'm assuming that no one else has access to them if you would have one, except for yourself and your doctor. But there's also specific patterns of data. For example, answers to a questionnaire, they can be potentially identifying. And this is really, since this touches closer upon the research data that we're gathering, this is something that we have to think about more. So what I had in mind is just to have a short discussion on which data you are collecting or which data you would like to collect for your research question and whether this is potentially identifying. So if we consider the data that we are dealing with, we have a gradient. On the one hand, we have clearly personal and identifiable data. We have a whole bunch of indirect personal data. So this is where a lot of research data falls. And then we're also collecting a lot of research data, which is actually in the green zone. And if we then think about like, how do we deal with this? I would say it's easy. And the other side is also easy. But it's in this middle section where personal data, indirect personal data, such as the EEG, being linked to other information, that's where it becomes hard, where it becomes difficult. The directly identifiable personal data, that's obvious. We keep it private, or we try not to collect it, and we don't share. We have a lot of data that is really the research data, and it doesn't really pose any risk for the participant. It's not identifiable, so we just share it with others. But it's in this middle section that it's often difficult, and we have to come up with strategies to decide how to deal with this. So the strategies that we use to reduce identifiability are to collect the data anonymously. And anonymous means, according to the European law, that no one is able to identify the participant. So taking a photo of a random person on the street, you can take the photo, and at that moment the participant is anonymous because you're not able to identify. But of course, if you take the photo, you can link it, and then all of a sudden the person becomes identified. So anonymous data collection is when you don't collect the name of the participant. When we collect our data, we often use pseudonymization. So if the participant comes in the lab, we use the name on the informed consent form, but we don't use the name on the EEG computer. On the EEG computer, we're going to use a pseudonym. We keep a table where the name of the participant is linked to the pseudonym, but all the data is stored under the pseudonym. So we make sure that the name of the participant is only used where we need it. And actually, at the end of the research, if we're done with the with the incidental findings procedure, we delete the table. So from that moment on, we don't know anymore which name belongs to which of the pseudonyms. We still have the names, we still have the data, but we don't know how they pair up, because we don't need to know which data was from whom. Then there's also a third strategy that we use, and that is de-identification. And with de-identification, we're really changing the data. So we remove indirectly identifying features. So for example, rather than storing the age, rather than storing the date of birth, we're storing the age of the participant at the moment that the scan was taken. We can blur the indirect personal data. So we can take an anatomical MRI and we can deface it. We can remove all the facial features from the anatomical MRI such that you cannot use reconstruction techniques to get the face back. When we use the age, we don't really have to use the age in days, because if you know when the scan was taken, well, you can still compute back and you would still know the date of birth. So what we say, well, we have the age in years at the moment that the scan was taken. And then all of a sudden, well, you know in which year the participant was born, because you know when the scan was taken, so you can basically compute back when was the participant born. But in that year, a lot of people were born, so that becomes much less identifying. But this is where it also really depends on the situation. So if we're studying babies, we're storing age in months or even in weeks. Whereas if we study elderly participants, so imagine this being a participant, like a 100-year-old participant living in Nijmegen, in the part of the Netherlands. There's not a lot of 100-year-old women living in Nijmegen. So in this moment, we could not store the age in years, because that would be very identifying for this person. So we store the age in age bins. And then for elderly participants, 5 or 10-year bins, or even wider bins, would be more appropriate. So we lose some of the details of the data, but we still have enough details so that we can do our analysis, but we make it safer for the participant. Any questions about this? Okay. So far this was very much on like treating the participants' data in an ethical, sound manner, but there's also legal constraints, and some of those we've already touched upon. So there are explicit and sometimes also implicit contracts between you, the researcher, and the funding agency. Perhaps the funding agency requires something from you. The ethics committee, I already mentioned that the ethics committee requires us to do the research in a particular way. But there's also the explicit contract that you have with the participant or with the patients, and that's the informed consent procedure. The participant signs for the informed consent procedure, but you have also signed for it. So if you write an informed consent procedure that you're going to do something or that you're not going to do something, you have to follow up on that agreement. There's agreements with the publisher of the results. Some journals require that you share the data. If you then have agreed with your participant that you're not going to share the data, then those two agreements are incompatible with each other. So that means that you have to find another journal, because sharing the data is not allowed due to the contract with the participant. So this is something that you have to be aware of if you engage in these types of contracts. And of course, there's also, like if you share data, you're making a contract with the other researchers that receive the data. And these contracts are called data use agreements or data transfer agreements. Oh yes, I had them like a little bit in more detail. So one of these legal constraints is the informed consent. And if you inform the participant about something, you have to live up to this. So that means that if you want to share the data later, for example, you want to publish the data, you have to make sure and you have to plan this in advance, because you have to ask your participant, which means that you first have to get your ethical approval. So it means like half a year before you start the study, you should already have thought about whether you want to share the data after the study. Because the ethics committee, in our case, the ethics committee evaluates the informed consent. So the ethics committee already has to see the plan for sharing. So there's really this handing over of responsibilities from the participant to you, to the future recipient of the data or of the research results. One of the licenses that we use, for example, in OpenEuro, is the Creative Commons license. And Creative Commons license comes in different versions. CreativeCommons.org is a website where you can see the different Creative Commons licenses. And the Creative Commons Zero, that's the public domain license. There's also the Creative Commons Share Alike, or the Creative Commons Share Alike with attribution, or the Creative Commons Share Alike with no commercial use. So there's a number of Creative Commons licenses. This is the one that is used by OpenEuro. And what this Creative Commons license says is that the person who puts this data in the database waives all the rights. And you can copy, modify, distribute, and perform everything with the data without any restrictions. In the Dutch system, this is not a license that we can use for sharing data. Because what we're basically saying to the recipient of the data, you can do with the data whatever you want. If the data is potentially identifiable, that also means that you can try to potentially identify the participant and use their data against their best interest. So in our institute, we have a data usage agreement or a data sharing agreement in which we say to the recipient of the data, so if you're going to get data from the Donors Institute, this is what you're agreeing to as a recipient. So you agree that you're not going to link this data to any other external database. So even if the MRIs would have faces, you're not allowed to use the face and link it to Facebook. We also say that you're not allowed to redistribute. We do the distribution, you're not allowed to redistribute, because we want to be in control who gets the data. Everyone in principle can have the data, but it goes to us, not through you. And then we also have some things like, I will acknowledge the use of the data, so if you use our data, we want you to mention that you've used our data. So you cannot claim that the data is yours. You always have to acknowledge that the data was ours. And if you do not abide to these regulations, then we could sue you. You're responsible. So this is really a contract. So that means that if you do something that is illegal according to this contract, you face the consequences, not us. And that is very different than this, because this basically says there's no consequences. So a few years back, we did a project, the Open Brain Consent project. And on the Open Brain Consent website, you can find examples of data use agreements and examples of consent forms that you can share with your participants, such that the participant knows well what's going to happen with the data after the study is complete. And that is something, so the link is not here, but that's something that I would recommend you to do if you're going to collect your own data and if you plan to share it. Already earlier in the week, I mentioned that we have this general data protection regulation, which applies in all European countries, but it is implemented slightly differently in countries, like in Denmark and the Netherlands. both part of the EU, but the interpretation is different. And even within a country, interpretations are different. And in the USA, there is something similar, but it's not as far-reaching. Because in the USA, they have the HIPAA, and the HIPAA is about protecting health information, whereas the GDPR is about protecting personal information. So the GDPR is much more far-reaching, and everyone who deals with personal data has to comply with it. A paper that I found while preparing for this workshop is from Kohler et al., where they did a survey of national ethics and bioethics committees. So this actually shows in a large table what are the different regulations that apply in different countries. So I don't know a lot about what's going to happen, so what's happening here in Africa. Damien is going to provide more details on that this afternoon, but it is important that you know what your local regulations are. So that's what I had to share about ethics and privacy in EEG research.